live, Brody. All right, man. Now, welcome everybody to today's class. We're doing episode of dryer repair here, live hands-on dryer repair. Today's situation is, let's give you guys a little bit of a backstory to this dryer. This dryer was a customer's who took it upon themselves to troubleshoot the unit. Now, by them trying to troubleshoot the unit, they cut some wires and did some stuff. So we took it upon ourselves that we're going to actually go through it, find the problem that they did, fix that, and find the original problem with the dryer and fix that. So we'll be doing live testing today. So welcome to today's class. I'll go ahead and pass the microphone to this handsome fella. Talk your stuff, man.
Well, welcome, guys. One thing I wanted to tell you is that...
Hold on 1 second. Apologies. So that these guys can see us. Right there. All right, go ahead.
Like we said, you're standing right there, like there too. What I said is that this dryer does have a problem in it. We did not attempt to pre-diagnose it. We wanted to go live troubleshooting, just like as if you went up to the machine for the first time yourself. We didn't want to know what the problem was. We know what the customer thought it was, and they decided not to fix it. So they gave us the machine. So we're going to troubleshoot it from the bottom up, just like as if we were going to someone's house. One of the first things we want to do when we approach this
let's make sure that our Zoom guests can hear us, can see us. Let's do some quick audio checks. Everybody can hear us good? Can you guys see us good?
No, muted.
Can you guys unmute yourself and let us know if you can hear us and see us? You got to speak a little louder.
Okay, I'll speak louder.
Thank you for the feedback. Okay, wonderful. Thank you, guys. Okay, as you were, sir.
All right, so the first thing we want to do, we have the top off, but first thing we want to do is we just want to see what the dryer is doing, if there's anything. So turn the buttons on, press power, pressing all the buttons. It's not responding at all. Open up the door, see if the light comes on, close it, check the light switch. Everything seems to be connected. When the board don't light up, first thing you want to do is just check to make sure that it's plugged into a power source. So I want to come a little closer. So we do have the back off and everything, but we're gonna test right from the outlet. So first thing we want to do is make sure you have power here. If we have power here, we'll go further into the machine. You do have these wires here, but a lot of times the machine's so close to the wall you can't get to them, but you do want to check the outlet. Now, one thing about these outlets, I want to show the outlet here. One thing about these outlets is these prongs here are very long.
Hold on. Let me not do not YouTube either. Let me give them this work. Let me give them this work too. Yeah, let me give them this work. YouTube, hey, we apologize, y'all. We trying to help the TMM academic group, all right? But we just bringing y'all along, so pardon the quality. All right, go ahead. Say what you said.
So these prongs are very long, and these outlets are very deep. Most meters, if you're trying to check voltage, first thing we want to do is put it on volts. So we have a few settings here. This is for temperature, milliamps, amps. This is voltage. If you notice, it's got a squiggly line and a solid line with a dotted line. That's both AC and DC. And when we look on the display here, we want to make sure that the wavy line is the one where we're checking, which is AC voltage. So to check the outlet over here, show the outlet. To check the outlet over here, we want to check the two prongs first. And I am getting a reading. If your meter leads don't read,
show the reading.
If your meter lead doesn't give you a reading, move the leads in the outlet left or right to see if you get a reading. If not, if your meter leads are a lot shorter than this one.
Bro, you getting a call.
If the meter leads are shorter on this one, what you want to do is plug in your outlet, and on the cord here, can you see the side of the cord right here?
Yeah.
You want to actually touch the metal spades, make sure that those are the only ones you touch. So if your meter isn't deep enough to get in there, and a lot of meters aren't, you're going to touch this metal prong right here and here. first thing we're checking is line 1 and line 2 for 240 volts. We got 209, which is okay. And then I'm going to check the left
Do it again.
one.
Show it again.
That's 209 there.
Yeah, I just want to see if they can see it.
And so now I'm checking the left one to the top one, which
Hold on.
is ground.
Why is it frozen on the screen? You guys can see it? Any audio problems? For some reason. Okay, now we're back. All right.
Okay. Cool. So when we're checking here, we check one side to ground. I got 120. The other side to ground here, I got 120. Now, even though we checked the ground, the very bottom one here, and I'll pull it back out, this one here shaped like an L, this is neutral. We want to check from here to neutral, here to neutral, here to ground, and here to here for 240. So I'm going to plug it back in, and I'm going to check to the neutral prong on the bottom. You want to shoot up from the bottom? And so now I'm going to go underneath here, and I'm going to check.
I did something. Hold on. All right, do it again.
So now I'm going to check one side to neutral.
Yeah.
And I got 120 volts there. And I'm going to check the other side to neutral over here. And I have 120 volts here. So I got proper power in my outlet. Since we do have access here, a lot of people would overlook this and not check the screws on the back of the machine. Okay, so make sure this one sees it too. So we want to check these here. Can anybody identify what is wrong with the way this is wired? Is there something wrong with this? Anybody have any ideas of what's wrong with the way this power supply is connected to the dryer? The YouTube feed sound and video is better.
That means we getting better audio from our YouTube than we getting from our Zoom.
So do you guys want to switch to our YouTube channel and then we can stream with one?
Yeah. Guys, can you guys please go on over to YouTube? For some odd reason, we're having better results streaming on YouTube than on Zoom. It may be because we're pulling all off one server.
The thing is, we can't see if they
I hope they can get that message.
The response on that. Can you switch to the back camera on that?
No, it's only a face phone. It's a Chromebook. Hold this real quick.
Okay.
Let's send a message to these guys.
There's no audio. We weren't talking for a minute there, so one moment. Brandon's sending you all a message. Some people are switching. Let's go back to
So then we gotta get out of this. Give me a second. I'm gonna add you to my stream. This is what I want you. Yo, go to YouTube.
Go to our YouTube channel. We're streaming live on there. We're trying to fix it.
So how are we gonna do it?
But it's not out.
Oh, okay. now I gotta add us to the block. Hold on.
We gotta figure out these cameras.
Yeah, this camera should.
We have to spend one day just messing with cameras and everything.
Wait. All right, we good.
Okay, switch.
I'm gonna make. My, oh no.
You can't be on both. Okay. Put the computer volume down on that one. Okay, can you guys hear us now?
Yeah, yes, now.
Yes? No? Okay, here. So you do this. Let's go. Rock and roll.
Patrick, if you still on Zoom, go over to YouTube. We having problems with the Zoom. Going over to YouTube, Patrick.
Oh. The question we have, guys, is this is the power supply and the power cord. This is a 4-wire cord that's connected to this unit. Can anybody identify what is wrong with the way this unit is wired? Anybody have any ideas of there is a problem with the way this unit is wired? Anybody have any ideas? Yes, no? If you don't know, put no, just so I know you're hearing what I'm saying.
Go ahead. Go ahead and dive into it.
Okay.
Expose the problem.
So I'm not going to unplug the machine, so I'm not messing with the line. When you have a 3-wire cord like this one, when you have a 3-wire cord that only has 3 wires, one is line 1, one is line 2, one is neutral. They use neutral here, this white wire, as a ground because the 3-wire cord doesn't have a ground wire attached to it. So when you're hooking up a 4-wire cord, you have to remove the neutral from here. Back up a little bit, please.
Okay.
So you have to you'd actually remove this neutral wire here. This would not be connected. You just tape it off, and you would connect the ground directly to the machine on a 4-wire cord. The idea is that neutral and ground, even though in the panel they're the same thing, what this does is this allows you to separate the neutral and ground and give them alternate paths in case one breaks, the other one takes over. So on a 4-wire cord, this neutral here would be removed, and on a range, it'd be like a brass strap going from here to ground. So now this is the way it is. It's wired up properly. So we do have proper power at the outlet. Let's just check proper power here and how to check the power at the input of the dryer. Okay, so we're going to go to our unit. I'm going to check 240 first, which is line 1 black, line 2 red. I'm going to check here. And we got checking power coming in. And I have 200.
Put the little light.
So I have 208 volts. That's enough to make it work. I'm going to check line 1 to neutral and give it a second to get a reading. Guess what? I don't have power there. Let's check this one. Something's wrong here.
No, that's wrong.
We have a problem.
Yeah. We got to get an electrician in here.
No, let's go back to the outlet. Check the outlet.
That's right, Rick. Get all adventurous.
Oh, we got to figure out. I'm going to check again.
Get adventurous with it.
Line 1 to neutral is, I don't have 120 volts. Line 2 to neutral, I have 208. I'm going to check the ground. I have 120.
You're slow, bro. Respectfully.
Oh, okay. And I got 120. So line 1 and line 2 to ground gives me proper voltage polarity. But when I check neutral in one of the lines, I don't have proper power in the outlet.
Oh, man.
So we don't have proper power in our outlet. So let's go ahead and let's troubleshoot that. We're going to go ahead and take our breaker panel off.
Oh, get adventurous, Richard. Let's enter into the unknown. I hit the like button, man. This is our first time plugging in this outlet, y'all. We apologize. This is the problem when you go live. All the headaches reveal themselves.
Now, normally, we would have pre-tested it to show you the problem, whatever. But when you go into someone's home, if you find out there's an electrical problem, you really shouldn't go beyond this outlet. At this point now, the customer calls electrician, because if you mess with this and someone gets electrocuted or the house catches on fire or something, you're responsible for whatever happens. So we're going to go ahead and just open this up and take a look ourselves what's going on inside here, because something's wrong.
Get courageous, Richard. Why not? Because I'm definitely not doing all that. At this point, I'm like, all right, y'all. Service fee, call an electrician. Anything happens afterwards, I'll apply the service fee toward the repair. Yeah, that's always a telltale sign that somebody else done been here. When you see different screws, they ain't all the same style. Yeah.
When we got this place, we didn't have no AC in here, so we had them mess with the electrical to add enough electricity to feed our air conditioner. So maybe they messed something up. I don't know.
Oh, Richard, who the hell you hired, Richard? Oh man, shout out to Hialeah. I hit the like button for Hialeah. Oh, look at this beauty.
Just a quick note, and this is a disclaimer: do not do this at home. This is dangerous if you're not paying attention. Okay, so we have, this is actually 3-phase, line 1, line 2, and line 3. This is our neutrals. Notice it's got white tape on it. How do I know it's 3-phase? This is black. They left the cable black. This is red. And if you can see right up here at the top, it's blue. So we actually have 3 lines, 240 from black to red, 240 from blue to red, and 240 from black to blue. And I'll show you how to test that. So again, you touch those things, you're going to kill yourself or hurt somebody. So be careful. These lines coming down are called bus bars. There's one here. You can't really see the one in the middle, and there's one there. And then this is the neutral bus bar on the side where you can see the white wires. And this is the ground bus bar on the right-hand side over here for our ground. So I just want to check to make sure that we have proper power in our input voltage here. So I'm going to touch these two screws here. And I have 209 volts. And you see the screws I'm testing. So that's black to red. I'm going to check red to blue. I got 208.
Okay.
And then I'm going to check black.
Wait 1 second, brother, because I can't. Yeah, the light goes off and I can't see.
So I'm going to go black to blue again. 208.
Yep.
And then I'm going to go black and blue, red and blue, and
209.
Okay, so they all have voltage coming in.
Yeah.
Now I want to find out, this outlet right here runs through this pipe. And by looking at it, I got one wire here, which is my ground. Okay. I got these two red wires here, which is running to this breaker right here. So this is a double breaker right here. First thing I want to do, that he has it listed as compressor. Let me see something again. It's not the compressor, but let's just go ahead and see. Maybe they had an air compressor in here before. I'm going to go check these two screws right here. This is coming off of the breaker for 240 volts. And I do have 240 volts. Okay, now I'm going to check each one of those lines to the neutral, which is right here. Neutral, and I'm going to check one of them. I have 120. And I have 3 volts right here.
Got her.
Oh, wait, I have 240 here. No? I don't have 240.
Yeah, you did 197. Well, yeah, you got it.
And then I check the neutral.
You're not on neutral though, bro.
That's neutral.
You're not touching it. Now you are. There you go.
I thought I was touching the screw.
Nah.
There you go. So I do have 120
Yeah, you
here.
got it in both.
120 here. Let's go back and double check the outlet. Here to here. I'm not getting proper voltage.
It's probably right up there. It's in there, bro.
I'm gonna check it, okay? And this one, I'm not getting proper voltage. So now we're gonna open this up. So let's go ahead and just throw the breaker. Well, I haven't got that. We're still at the power coming in.
I'm gonna keep it real with you, Rick. I never explore this. I don't dive this deep. I get to this part, I refer an electrician. Talk about it. Good adventurous.
I've been enough of this stuff here to see what's going on. So I'm gonna go ahead and pull this outlet out. And guess what?
What's up?
We don't have a neutral.
We don't even have a neutral.
Look at
that line of work.
Ground, neutral, line 1 and line 2. I'm gonna take this and let me see something here.
Richard, are you sure you want to get into all this stuff, man? There's work that needs to be done on the drive.
Oh, we can't test the dryer until we got proper power.
We got that harness we could fix. Remember, that harness needs work. You don't have to have like a dead man stick or something to whack in case it gets stuck. Oh, definitely.
Okay, so I'm gonna take this ground out of here. So I know we gotta later rewire this outlet for all 4 wires. I'm gonna take this ground out of here. This ground don't have no power, so we good. And I'm gonna hook it up over here on this side to one of my neutrals that doesn't have a wire in it. So I'm gonna move this one over to neutral. But before I do, I'm gonna move the ground that's on here to the neutral side where we didn't have power, because ground is a safety and we do have to run another wire, but we don't have it here today. I'm gonna move that ground over to the neutral side for testing purposes, and we'll go back and test the dryer out again.
How much would an electrician charge for this? Oh, I'm in the wrong line of work, B. Oh, nah, I'm just kidding.
I got power there. And where's that ground go? Here. Let's stick that ground in there. I gotta twist it a little bit more. solid wire is better for something like this, not stranded wire. Stranded wire is a little bit hard to get it inside that little bit of the hole, but twist the pliers a little bit, trying to get it.
Talk about it. You're doing a wonderful job, Richard.
Oh, thank you. I'll send you a bill when I'm done. So I'm going to go ahead and stick that wire in there, in the hole here in the back. I'm being very careful not to hit where the breakers are. I'm going to have to take that screw out just a little bit more. Screw's probably too far down. I'm going to have to stick that wire in there. Still not far enough. Okay, I got it in there. Tighten that down. So I'm going to turn this breaker on now, and I'm going to check line 1 neutral, line 2 neutral, even though it's pretty brown.
Yeah. It should be white.
I'm going to start the dryer and see if it starts up.
Oh.
Okay, so we're going to go over here now. I'm going to check 240 coming in. I have 220 there, and I'm going to check to the neutral leg. I got 120. Check to this neutral leg, and 120. So that's good. Let's break her off.
See that? Oh, he's small, man. I'm not. I know my limits.
I've actually replaced the fire panel.
Talk about it.
Remember Hurricane Andrew, the guy's panel blew up and power finally came back on and he had no power in his house. And when they were putting the closet in, they screwed into the back and actually the screw was touching the panel bus bar. Hose on the closet. He was getting electrical shock. Yeah. All right, let's move the. All right, so we're going to plug the drive back in now that we have a neutral. We don't have a ground as a safety. At this point, this ground here is not doing anything in the wall, so this white should be reattached back here for safety purposes. I'm not going to worry about it this moment, but since there is no ground, this is acting like a 3-wire cord, just like the gray one down there. Okay, so let's go back over here and just check to make sure that we still don't have power coming onto the board. Open and close the door. And the board's still not powering up. So let's go ahead and let's take a look at the schematic now and say, okay.
Talk about it.
Our power comes. What we want to do is check power on the machine. So the first thing we did is we checked power on these. We checked power on these three here, which is the input power on the machine. Okay. And if you back up, we can show the circuit. So what we want to do is we want to check power to the main board.
Let me see if rotating it will work better for them. If rotating it like messed y'all up, let me know, okay? Beautiful. I think that right there, we got it. Yeah, we got it. Y'all can see that good? Let me get some comments and see if they can see this. All right, good.
Okay, so let's follow black coming in. The black comes in through here. Oops, let me erase it. My finger slipped on the table here. So black comes in and goes up. And it goes into the board here. Also,
2P pin 2.
Yeah, 2P, pin number 2. It's also a black wire coming in and neutral. Most units, even 240 volt stoves and 240 volt dryers, it takes 120 volts coming in to feed the main control board. There's very few boards that actually, the board itself works off of 240. So the two that we're looking at is neutral comes in, it comes up, and it comes in and it feeds the board here on a brown wire. So this is plug 3P
pin 1.
2P. Now, let's take a look at this plug a little bit. Back up just a little bit. So this is 3P, but it's also CN1, connector number 1, connector number 5, This is relay number 5, relay number 6, relay number 7. This is connector number 4. So these things that are saying relays, they're external relays on the board. Hold on a second. I have a board. So the connectors that they're talking about there, and then zoom out so I can see this first. So like this connector 4, if you look at how many wires here, 7 is the highest number. So that's probably a 7-pin wire. 1, 2, 3, 4, 5, 6, and 7. Notice they're not in order, but they will be in order on the machine. So if you come down here, we have 1, 2, 3, 4 connectors on this board, and it will be a 7-pin connector. Now we'll have to look at the wires to try to see what connector it is. But the other thing that we notice is it says white here. So it's one of these 2 white plugs on the board. Okay, so if we look at this connector number 1, it says 1, 2, and 3 on the connector, and it's a black plug. So if we look over here, we do have a black plug here, but that doesn't have 3 connectors on it. So we have to find those connectors, and they're probably this input right there. Okay, and if we look at this unit, this piece right here is the power transformer. This is what we're trying to feed with the 120 volts to make this whole board light up. So we're going to go back to the machine now. We're going to look for this brown wire here on connector number 1. And we're going to look for this black wire here on relay number 5. Now, relay number 5 is also the motor relay. If we follow it down here, it goes to the motor here where the centrifugal switch is. And down here it says motor. Okay, so that is one of these relays here. Back up to a little bit.
No, I had a good angle. Go ahead.
Okay, so that's one of these relays here. Now notice these big terminals here and then these smaller terminals here. This is most likely our heater relay, and it would be there to control the heater. And this is probably our motor relay here. So we're probably going to find the black wire coming into this relay, and the brown wire maybe one of these 3 on that plug up top here. So let's go to the machine now, and let's see if we can find that input power coming into the machine. First, let's unplug it before I take off any panels. I'm going to go ahead and come here to the main control board here. Again, remember, we didn't pre-diagnose this, so we're testing it for the first time here.
On the fly.
The guy, backstory though, because y'all saw a board, the guy told us that he thinks it's the board. He's an engineer. So we went and bought a board just in case. But maybe it is the board, maybe it's not.
All right, so we're going to go ahead and this is that same board that you saw in a minute ago. And so there's some wires here that were taped off. We sort of like separated the white and that wire there. What we're looking at here is if you look here, this one has the blue and the black. Let's go real quick back to the diagram. I'm looking at all the relays here, and we got a white and black and a blue and black. That relay there is for the heater, that blue and black one. So that's not the motor relay. I'm trying to find the motor relay that has brown and black. When I find that relay, I need to check that black wire. Because if I'm following this black wire here going into that other relay that I just showed you, it goes through a thermal cutoff, and it goes to a relay here for the heating element. But that wouldn't supply the board with power. We'd have to have power to the board all the time on this black wire here. So that wasn't the right plug. So let's go back.
Let's also please hit the like, subscribe, and share button. Why not?
Okay. And most likely it's going to be this plug here. And look what's right next to it. Blue and brown. So we want to check black, blue, and brown. I'm gonna untangle these wires for a minute. Give me a second. Black is the power here. This really is not a big power supply, but we don't need a lot of. Notice the wire sizes. This black one is a lot smaller than the brown and the blue. The reason why this gauge is smaller is it's only feeding the transformer on that board. So we got black there. Now we need to find out what other wire are we going to test. We needed a brown wire, right? So we need to find the incoming brown wire, and that was which connector? That was coming here. That was blue, black, and brown. So that 3-wire plug right here, we're going to check that brown one. And the black one that we said coming in, let's follow that black again. It comes over here. It jumps, and it goes to black here. So that's the incoming power, black and brown. Those two right there is line 1 and neutral. Even though it says brown, if we follow that brown back, it connects to the white over here. So we want to check that black and brown from that plug that I just connected and see if we have 120 volts right there to feed that board.
Okay.
Now, when we're making the test on the incoming plug here, we don't have to press start or anything. As soon as the dryer is plugged in, it should give us a reading of 120 volts immediately. Let's turn this on so we can see it. And when you're checking a plug or a connector like that, don't go from this side of the plug. You can spread those out so much when they connect to the board, you don't get a good reading. What you want to do is stick them in the back where the wires go like this. And the machine's still unplugged while I'm doing this. I'm doing this machine unplugged. I connected my wires in there. Hopefully I made a good connection in there. Made sure that they're not touching the metal here. I got to make sure that they're safe too. And my meter's set up on AC volts, wavy line there, and I'm going to go ahead and plug the dryer in. And we don't have 120 volts coming in.
No. Check your volts.
Make sure I plugged in there good.
Black to chassis.
Okay, so I'm going to check black coming in. And chassis, we don't have chassis connected. So I'm going to go to neutral here. And see if I get power from black to neutral.
No, the breaker's off though.
The breaker's off. Well, should do this while it's unplugged, but let me unplug the machine while I'm doing it.
You don't want to get that bite.
Yeah.
You don't want to get that tickle.
It's more than a tickle.
I've been 120, but thank God, where's wood? I ain't never get
two.
It
wasn't my fault. It was a trainer.
I had the 120, but not the 240.
Okay. So I'm still connected in here. Checking black to brown. And, oh, actually, I'm not black and brown, am I? I was supposed to be black and brown. I was on black and blue. That's unplugging and checking again. It was black and brown, wasn't it?
Yes.
So I was in the wrong color. Walking back and forth, not having the diagram right in front of me makes it a little more difficult.
You can't get all right.
Black to brown. I'm not getting proper voltage. So I don't have proper voltage. So what I'm going to do is I'm going to backtrack. I'm going to leave the brown one in there. And I'm going to move this one over to black here and see if I got 120 here while I'm on the brown. Okay, so let me go back here and just see if I go for the front side. Just maybe it wasn't making a good connection to the black there. I'm still not getting it, am I?
Let's look at that schematic one more time.
Well, that's not black
wire. P2. No.
That one. Black and brown here, 1 and 3. You notice how the brown was on the outside and the blue was in the middle physically. But look at the number system. Number 1 was brown, number 2 was blue, black is 3. So 1, 2, 3, how we really see it The numbering system here is different. The brown is on the outside because it is number 1. Blue in the middle was number 2, and black was number 3. So we check brown and black. If we follow them back, black here jumps off of the water valve, comes around here.
Okay, you jump water valve
No,
1, water valve 2.
We do have the wrong black. Look, this is the wrong black. This is going to the centrifugal switch.
It's this one here.
It's this black here on this plug here, a 2-wire plug.
2P.
Brown and black. Okay, so we got to correct ourselves.
2P, 2.
I need to have this diagram
It's all
in front of
good.
me.
It's all good.
So we're going to check black to brown.
Yeah.
The brown on that one, we got to find this black and brown.
3P brown, 2P black. 3P brown. My bad, y'all. We little got lost here.
We didn't do this ahead of time.
There goes. Okay, where's P2?
Black and brown here, huh?
Yeah, well, let me see. P2 and P3. Once I see that, you got a light, brother, so I can see the board. Okay, yeah, that'll work. Let me see. Okay, there go the resistor. The relay on it. Relay 401.
That was relay 5.
Give me 1 second.
I'm just
brother.
going to go to the black one there.
Go ahead.
So, we'll check this black here. Check this black here. This one I can plug in from the front because the terminal's big enough. And I'm going to go to the brown on this one. If I have 120 here, what does that mean?
That your board is getting good incoming voltage. We're not plugged in.
Yeah, I know. I want to turn the light on here first.
Hold it. All right. Jackpot.
Okay, so we have 120 coming in.
So that means, in layman's terms, our power supply is good enough to power our board, which then should go ahead and send a VDC, volts direct current, to our UI, which is not well, we don't know if it is or it isn't because this isn't being responsive. So we're going to check output voltage to the PC UI.
This is the connector between the two.
Yeah, but it don't tell us which one.
We don't know which ones our voltages are. So even if we had a plus or a minus, we could tell. But usually with DC volts, usually red and black follows like car batteries, red and black. That would probably be the DC voltage on that plug right there if we wanted to check it. I don't know if we got terminal small.
Oh, I do, bro, but I'm not.
Okay. So just anyways, if we wanted to look at it, that red and black would be these wires right here on the very end. That's these incoming wires right here.
Take them out. I'll take them off.
Well, I'm gonna go ahead and just swap the board out real quick and see what happens.
Remember, we still got these wires. We got to flex and
Well,
fix.
they're connected together.
Okay.
We got one taped off and the other one's not. So we got to just make sure you don't touch each other. So that's unplugged. Let's get the meter out of the way and let's make it so we got. Hold on one sec. Let's move the meter. So we can unplug it. So if the guy diagnosed it right, I'm going to offer him a job and see if he wants to be an appliance technician.
Oh, he said he was an engineer or something?
Yeah, he was an older Chinese guy. And him and his wife were actually pushing this thing to the curb when I saw him. And I said, man, it's a nice looking dryer. I said, can I help you with that? Yeah, we're going to, whole pickup is coming and they're going to pick up the dryer. So I said, what's wrong with it? I have a company. I'll help you out. He was a neighbor of mine. I just moved into a new neighborhood. No, it's a bad board. We've already decided to get a new one. It's being delivered tomorrow. So
I'll take that.
I couldn't get the sale, but I did get the machine. So I said, okay, well, let's see if we can fix it and then maybe get a good working dryer out of it. So I'm probably connected back to it.
If this thing fires up, we got a dryer for the price of a board.
Anybody want to buy a dryer?
Facts. OffenRough.com.
TMM special.
Wow. scratching there. Looking good, Richard. Looking good.
Look like I know what I'm doing? I don't know. Okay, I want to make sure that this white, even though they're low voltage, I want to make sure the white and the red don't touch. Let me just put a little tape back over it. Because I'm going to lift it up, because if the dryer starts, I don't want the board sitting like that on top of the
We're going to repair these wires, y'all. We're going to show y'all how to solder and repair that. I'm going to show you that.
We're going to do that next.
This is rinky dink for now, just because we're trying to fire her up. But we're going to leave, this thing looking the right way.
Just put one screw in here, this for safety. That's good. All right, let's plug it in.
I knew he ain't know what the hell he was talking about. All right.
Let's double check our voltages again. Now listen, one thing I want to tell you that this happens a lot. You diagnose a board's not working or something, and you put the board in and the machine still doesn't run. Don't all of a sudden say, oh man, what do I do? You want to start from scratch again, like as if you never.
My bad, guys. We having trouble with his phone.
Yeah.
We back? Alright, we back. Hold on. Hold on.
Okay, going back to what I said is that.
Wait. Let me take this one off. Hold on. No. Enter studio. Hold on, Rick. I'm gonna add this. What did we do last time? Oh, we zoomed this.
All right, cool. We back to how we was.
Sorry about that.
Sorry about that, guys.
We still got to learn how we're
learning this stuff.
going through multiple cameras. So while we're trying to teach you something, we're trying to teach ourselves. Okay, it happens a lot where you go and you replace a part and the part don't work. And the first thing you say is, oh no, I screwed up. It's got to be something else. And you go crazy tearing the machine all apart. Don't do that. When you change a part and the machine don't work, go back to square one and do all your tests again, just to double check. Make sure you still got proper power coming in. I'm going to go ahead and check power coming in. I'm going to check line 1 to line 2. I got 208 volts coming in. I'm going to check line 1 to neutral. I got 120. I'm going to check line 2 to neutral. I got 120. Let's go back to the board, make sure that I connected everything properly. Don't get flustered that you change the board, the machine still don't work, and now you say, I don't know what to do. Go ahead and just do like what I'm doing right now. Just going back and just double checking everything. Maybe something else came loose or something connected properly on the board. And it's connected. I know that that red and white wire was connected. These are all connected here. Everything seems to be connected. So we're going to double check one more time our input power, which was black to brown.
We had 120.
We're just going to do it one more time. Just make sure we didn't lose it by missing it. So I'm going to go here. And I cannot reach that light from the back. So I'm going to have to plug it to the reader.
What you trying to do? Oh, okay, okay. You measuring 120 at the board.
Coming to the board again, just like we did before.
Yep.
I'm gonna go black on this plug, which is the top one, isn't it? Yeah. So this one right here, black, and this one right here, brown. Stick that in there tight. I'm gonna check black to brown. 120. Okay, so now it comes to, okay, now what do we do? We change the board, and most likely user interfaces.
Can I take the camera for a little while? Record me. Let me.
How come I can't see? I see just a camera. I don't see something.
Guys, let me show y'all something. Look, let's think about this, right? Forget all this nonsense. Let's think about this, right? We got this user interface here. It needs 7 volts VDC. That gets power from a main board. This main board. This is how I think, y'all. This is how I make my appliance repair easy. Main board. This needs 120, and then the dryer itself. You know, it got to be properly polarized, which we did. We made sure we had 120, and we made sure we had 240. So we checked from the dryer, right, from the terminal block, going to the board. We made sure that we had 120, which we did. But now we get to this guy, right there. And we not getting no action. And right away, the first response to the other guy who originally troubleshooted this was, oh, it's the board. And that's what we went with. That's not how you do it.
So you didn't check the input to the user interface.
The way you got to troubleshoot, you always verify correct polarity at the wall. Measure it down to your terminal block, which we did. After that, go to your main board, 120. Come over here and follow me. Coming off this board here, this L1, it clearly, a black line, clearly, right here, this is a node. This node went upward and it went over that into this white 2P connector, right? So that's our L1. And then our neutral went over here to black 3-pin brown. So with that, that's how we checked and we got our 120. Now, we good here, but we not having no action over here, which is at the touchpad. So now what we gotta do is measure the output voltage here, because this may not be responsive. That's why it's not turning on. So we got the wire harness that may be questionable. Maybe there's a break in one of these wires, or this UI itself is getting the VDC, but it's just failing to power up.
Okay, one thing I just want to add, which is everything he said was correct, but we want to check output voltage right here. If I have the 5 to 7 volts, then the main board's doing its job. If I don't have the 5 to 7 volts, we got to go back this way again. But if we have the 5 to 7 volts here, then like he said, it's the user interface or the wiring harness.
And how, and put the camera back. This, like Richard said earlier, right? We don't have no plus, minus. We don't know how to check voltage for this. But what I'm gonna do is I'm gonna use two black. Yeah. And if that don't work,
red is most likely positive. Black is going to be ground, and we use those colors. Those colors are pretty standard on most machines. That's just the connector to the user interface. So it's this one right here. Let's see these wires right here. It's these wires right here.
Chafing here too. You see that? Look at this chafing. We may have a busted wire.
Let me see.
Right there. Look at that chafing.
It's a little blurry, so I can't see it.
Let's check the wiring harness. Let's do a wire harness check.
I thought we working on Saturday. Let's do a wire harness check. Zoom out a little.
Maybe that's why he disconnected the red and white to check the output. He checked red to white instead of red to black.
Alright, so look guys. Well, this is our wiring harness, right? Right? This is our wire harness, guys. So, which one was it?
Wait. Look right here.
That's for the light though.
You sure?
Yeah, I believe that's for the internal lamp. But let's check it for VDC.
Usually black and red is the power coming in. Okay. Plug the machine back in. Okay, he's switching now to DC volts. And if you look right there, the meter now, instead of a wavy line, is a solid with a dotted line. That means he's on DC voltage right now.
Look, if it's a little hack, y'all. If you don't got leads that could go there, this a little hack that I'll do. Everybody got their own thing, but look.
You got those little metal prongs right there? Let me get the camera. Okay. I'm gonna get the camera so they can see what you're doing. Okay, I'll hold it. Hold it down.
No, that's not it. I don't think that was.
That's power, red and black. I'm almost 100% positive. That's gonna be
look, it's going to the lamp, bro. It's not getting no power. This is.
Then red and black on that one. So find the
same. Okay.
Red and black. Come closer.
Oh, so we getting no micro, no milli.
We're getting millivolts. We shouldn't get millivolts. We should get 3 to 5 volts, maybe 7 volts.
I'm gonna go
switch from
milli.
milli.
That's what I'm gonna do. Hold on. No, can you keep that like that, brother? Let me do this real quick. Let me try. There you go, right there, milli. Hold on. Because what I'm doing is I'm using the black and trying to find.
I'm trying to show everybody else what the readings are. So what he's doing is he's holding it on one wire, and he's checking all the others to see if he's getting any voltage reading. Wait, go back. You had almost like a 16.
Milli. Not getting output voltage. All right, let's check now the resist. Let's check the wire harness continuity.
Plug the machine.
Which one is our connector?
The one where the wires are cut.
All right, this is a perfect time now. Let's fix the wires.
Let's check it real quick. And then see. Are there any other ones?
Fell apart though. We're gonna slice the product down.
So he cut red and white where he probably should have checked red to black. I don't think the red and the white is the power coming out of that board. So he did the same thing, or at least the same thought that we did, that the board isn't sending power to the user interface. And he probably didn't get no voltage on the red and white. So at that point, he assumed, okay, the main board's not sending power to the user interface. And that's why he went ahead and switched to that.
Okay.
And this leads into the board repair class that Brandon's coming into.
Yes. Board repair class October 30th and the 31st. Come down, learn how to troubleshoot boards, board repair.
And checking voltage in and voltage out is how you're going to do it. So,
this here we're going to need a little
connected to the 2 light bulbs.
We don't got nothing to work with here. Let's do a little search. Just make it look pretty. That's all I need. So right there. How's my other guy? Beautiful. All right. So what we're gonna do is let's get these two together. What would be nice is if I had like some extra wire.
Take some of that tape off. If I remove some of this tape, though, you might get some more slack.
Yeah, when y'all do this, y'all want to make sure y'all soldering iron's hot enough.
Hold up for a second.
What's hold up?
Hold the phone. Try to give a little more wire here so you can do a little more work here. But go ahead and twist them together a little bit. And now when he's ready to solder, the wires are connected already. That was the two whites, and now
one at a time.
I'm just gonna twist them together like that, and then you can solder them both at the same time. I moved the tape back so it gave you some more slack on them wires. Go ahead and do the red one, and then we'll do the. Now, when you solder, you need to make sure. You need to make sure that the wire is hot enough for the solder to stick to the wire. So he put a little bit of solder on the soldering stick, and then once it gets hot enough, it should transfer the heat to the wire.
Still not hot enough. Give it a second. There you go. Okay, she's good now. That beauty, huh? That beauty. Richard Zuka. What do you think about that guy?
I couldn't have done better myself. Remember, I fixed the outlet. We're even.
Both find their way out of it, Richard.
Oh, hell yeah.
I was gonna take you to Checkers. All right. Hold on, bro.
After this is the date.
Negative. You owe me, remember? Hold on, y'all. Y'all see this? This is what I'm gonna show you. Hold on. Watch this. Look at this. Check this out, y'all. When that happens, look, y'all do a little move like this. Look. There you go. And then pinch them together. And now she ain't going nowhere. All right, cool. Really cool. Up the like button. YouTube's premiere.
Now, these wires were supposedly connected when this guy was doing the test, but he checked red to white instead of red to black. Now, most manufacturers don't give you the voltages and everything else. You're just going to have to get it best yourself.
I'm just making sure that liquid flows all in there. All right, we good. That's a beauty. She ain't going nowhere.
Tape on them so they don't touch each other and short out.
Oh, let me just make sure that they good.
So those are the two wires we just prepared.
Check this red. Oh yeah, that's good. See this white? Oh yeah, she's good. Now we tape them up.
We should just plug it back into the board and test it one more time. Maybe they were never making good connection all along after we changed the main board.
That's why I'm a big proponent of soldering wires, man. It gives a good contact.
Let's do all I can, and let's plug it in and test it. You can see it all the way.
Okay.
Taking my time. You don't need the light. We just want to see if the board lights up. Just hold it this way. We don't have to start the dryer. We don't even have the board lighting up. So let's check that out.
Oh,
Go ahead.
we not plugged in.
Oh, plug in all the other connectors on the board.
All right, now we got it. Beautiful. All right, cool. Well, we expected that. We didn't necessarily rule that out. I would like to run another check though for voltage.
Yeah, we'll redo that. The one thing I want to say is, if any of you watched that GE range video, make sure you check out part 2, where I identified where GE actually made a mistake on their factory wiring diagram, and we had to troubleshoot that out. The black and red, we don't have nothing. Can't see what you're testing at all, though.
I'm just going pin to pin.
They can't
Oh,
see.
no, millivolts.
Trying to show the meter and what you're testing at the same time, but I'm gonna put it like this so we can see it.
It's
That's all millivolts.
yeah. I'm checking to ground at this point. I'm just seeing if we even getting. Nah, bro, we're not getting output voltage. All right, so let's check it. Now let's check the continuity of the wire harness.
All right, I'll plug it.
We're gonna go color to color.
And one thing you need to make note is just because this plug and that plug go to each other, they're not always the same number. Like if it's the black one's pin 1, it doesn't mean the black one is pin 1 here always. So don't go just by the pin location. Make sure you go by the color of the wires. Just unplug this one up. Unplug these, and that way you don't have the Okay, so he just taped them down so they don't move. Put the meter so I can see the meter and your tests.
That was going ohms. Continuity. Let's verify that. So let's start with
Black on the end?
yeah, black here.
Good.
I got 2 blacks.
Well, that one was good. The next one is what?
Black as well, but it don't have. Let me see this. No, that black. All right, let's check red.
Just touch them all. Okay, that one reads.
Okay, let's go white. Okay, let's go pink. Let's go yellow. Come on, yellow or pink?
I can't tell. Look at the camera.
Okay, yellow's good. Orange and blue.
All the wires are good.
Hold on, blue. I'm not getting blue. Okay, blue. All right, so our harness is good. Go back to my illustration. All right, y'all, so look. As y'all see, let's redo this again. We got our dryer. We said 240, 120. We checked terminal block and we checked board input voltage. Board input voltage. So this guy's good. Now main board, we verify 120. We know that wire harness is good. So now the output wire harness that goes to our UI, we verified all those little pins, and they all check good. So this guy's good. This guy's good. Just by rule of deduction, it rules this guy as our culprit.
I want to make one more test here. Hold this for a second. Okay. So we found this. Let me erase this for a second. And remember, we're going just by what we have on information. Is we said that this here is going to be our neutral to the board. Neutral has an alternate path through the door switch to blue and to the motor here. There's no way that the control board would feed through a door switch, because every time you opened up the door switch, the board would shut off. So this neutral has to be the neutral that's going to feed our unit. Now, while we were looking at the diagram, the only other thing I'm looking at is this black wire. And because this one goes directly to the board, I assume this one is the one feeding the transformer. I do want to check, just for the heck of it, we have an alternate path here going to the board here. Maybe the transformer's here. I don't know, because it's not drawn. Whether the let me see if I get my pen here. It's not drawn here that my that's no good. Let me erase that. Let me go real small. The transformer could be on this wire. I don't know. And then the neutral on this wire. I'm sorry, on this wire here. Let me fix it. I don't know which one of these black wires coming in is feeding the transformer on the board. So I want to make one more test and see if this thermal fuse is good. Because if this thermal fuse is bad, then board power won't come in here on this black. And if the transformer is connected to this one and not this one, then that would also stop it to work. So instead of going down to the thermal cutoff, which is down inside the machine, we do have pin 1 here on the board, and I could just use black on the power supply coming in. So I'm going to check this plug on the relay, black and blue. I'm going to go black and black on the power supply and see if we have continuity on that. You want to make that test for me, Brandon? I'll show you. I was watching. Yeah. So I'm going to go black on the power supply.
Oh, we got some. West Coast, what's good, man? Did we check? What he said? Did we check? Did we ever get 5 VDC output from the main board?
That's what we just tested, and no, we couldn't find any of it coming out.
Look at like many folks.
Yeah.
West Coast. Let me see who else.
And because the schematic doesn't tell you which 2 wires, we had to check them all to see if there's anything we could find. Normally, we follow the rule of thumb, usually is red and black, red being positive, black being negative. But, you know, these manufacturers, this is a Samsung dryer, and they're made in Korea. So we're trying to just do the best we can with the schematic that we have. So
says the motor clicks and it doesn't start, and you can spin, brother, but we can't even get the UI to turn on. So the motor is even, we can't even get to that far.
The motor has to light up first before the motor even does anything.
All right, I think we're ready. What's good, Untamed, Home Tech, R2, Hidden, Scat, BK, Gaspar, Rose, and Pitcher Man. I think we shouted out everybody.
Okay, let's just check that one last thing. So we're going to check black to here to black on the power supply coming in. So,
Continuity?
yeah, we're just going to check continuity black to black. You might have to unplug it here to get to that one. And then we're also going to check black to brown on this one too. We're just going to check all the blacks to the power cord. I'll hold the black in the back. So we know that that one's also feeding power to the board. And this black is good. So we got power coming into that board. We've already changed this board. We cannot check the UI output voltage on this board, but we're using 2 main boards. It's very hard to say that the board's the problem. Most likely this user interface is our fault. There's the only thing left.
Rule of deduction. And that's because we get in voltage from the receptacle to the board. We verified at our terminal block, we had our correct wire configuration. We had 120 to neutral, L1 to neutral. We had 120 to neutral, L2 to neutral. So we know and we had 240 across. Then we made sure we went to the schematic. We made sure we had proper input voltage from the board now. Brand new board, output VDC. We weren't getting we haven't checked output voltage, right? We did. And
yeah, that's what you check from the plug here, yeah.
So then we're not getting output voltage when you have a bad board.
It would be if we knew which two wires gave us the output voltage. And believe it or not, I do want to say one thing. It's hard when you have multiple boards inside of a machine because you don't know what output is going on what two color wires. If
you want to check that your board is working, check the thermistor. It will provide VDC to it. It was a 7P. What harness was that? A CN 802, CN 5, CN 201.
CN, by the way, means connector. So connector 5 or connector whatever. Now this UI actually has two boards. This is the dial and this is the display itself with the touch panel. If I was to replace anything else, this would be our next option. I'm going to go ahead and order them Monday. Let's see if that corrects the issue, and we'll let you guys know what we find out on it. What are you looking for? Let me take a look at the schematic. You're looking for the thermistor for the dryer? So are you looking at thermistor 2? That's a 7-pin plug, connector 4, and that's 2 to 7. Tell me we're messing with the wrong dryer diagram. That's not the wrong one.
That be Samsung using multiple schematic for various drawers that are very similar.
Yeah, but they would all be the same connector, same wire. This one had the water valves on the bottom like that schematic too.
Let's check output voltage to the thermistor.
Which one is the 7-pin wire? It's not this one. This is the UI one. Well, how are you going to check output voltage if the board don't light up? You have to turn it on to get the output voltage.
But we know we got voltage coming into the board.
Yeah, but it won't output voltage there until the UI tells you. So it was a nice try, but I don't think if it's not going to light up, it's not going to put the output voltage.
I got a battery. I got a 9-volt battery. Let's put it. You want to try to?
We don't know what two wires.
That's true. We don't know what to. Damn it.
So we're pretty much stuck here. Like I said, I'm going to go ahead and order this UI. There's two pieces. You see, there's one board. There's one board here and one board here. That one board is the dial, and the other board is the touch panel. So we're going to order the touch panel one and see if we can get this thing to light up. Most likely, that is where our fault is. We just don't know the voltage we're supposed to get outside this plug.
Yeah, this was a good one. This is our guy right here.
Now we see why the guy didn't want to fix it. He didn't know what was wrong with it.
All right, y'all. So listen, guys. Want to thank y'all for joining us on a Saturday. This was live, and when you do live, you run into the electric, you run into this and that. But all in all, let's take away some notes. Let's take away some important things. Look at appliance repair like building blocks, step by step by step. Proper voltage input, proper voltage at the dryer, 120 to the board, output voltage from the board to the UI. Verify that your wire harness is intact. And after you rule all of those out, then that's how you can make a safe, like comfortable diagnosis and condemn the UI. And we're gonna get the UI and plug it in and show y'all that that's it. But that's how you do troubleshooting. You just don't make careless you know, I think it's that, or I think it's this, because you'll run into you'll buy the board, that's 120, 130, and then gotta buy the UI, which is another 120, and then you gotta charge your labor. You gotta talk yourself out of a job if you keep misdiagnosing. And again, guys, October 18th through the 22nd, don't forget going over to tmmacademics.com/hands-on training. And all those refrigerators back there, the evaporators, they gotta come out. We got a lot of compressors, they gotta come out. We got a lot of schematic training we gotta do. A lot of from the board testing we're gonna do. So please go on over to tmmacademics.com/hands-on training. Also, finally, this is the last one. Come on down with my good friend Tony, CEO of Board Busters, where we're gonna be going over how to check relays, how to actually remove them, how to put them back in, checking your capacitors, your resistors, diodes. Again, email me if you're interested. We didn't create a link on the website, but just email me. All right, that's all I got for you. Love you guys. Let me leave Rick with some final words.
Appreciate having you. We're going to do some more things like this, and like I said, we'll be more streamlined as we learn how to do this properly. Thank you. Have a good weekend.
Thank you, guys.